Right, grade 12s, what we're going to do here is just have a look at 2017 November. Okay, this was a good year for physics, and especially for the VPM question. All right, exceptionally good question here, and I've done it many times with students of the past, and they have enjoyed this question and definitely learnt a lot from the question going forward. So, question 3 is your standard VPM question in your November exam. Okay, it always comes in at question 3 99% of the time. In this question, stone A is projected vertically upwards, as we see in the diagram, at 12 meters per second from height h above the ground. Ignore the effects of air resistance. 3.1 says calculate the time taken for stone A to reach its maximum height. Okay, so let's attack that question first. It's a simple 3 marks. I'm sure that we can nail this question. All right, let's go have a look at it and let's engage with it, and then we'll come back to have a look at the solution. Next question, okay, is at the same instant that stone A is projected upwards, stone B is thrown vertically downwards from the same height at an unknown speed of v. So we've replaced the we replaced the unknown speed with the letter v. It's a variable. We still need to solve it. Refer to the diagram below, and we see a beautiful diagram sketched there. When stone A reaches its maximum height, the speed of stone B is 3v. So how do we read that sentence? That when stone A reaches its maximum height when it was projected vertically upwards from height h, okay, at 12 meters per second, stone B is already 3 times its original unknown velocity. 3v, it's 3 times greater. Its speed is 3 times greater, or 3 times faster. 3.2 is calculate the speed of v with which stone B is thrown downwards. Okay, so though we see 3v here, we're just trying to calculate v, which is initial velocity that stone B was thrown downwards with. Okay, and at for the next question, at the instant stone A passes its initial position on its way down, stone B hits the ground. Calculate height h, and then sketch a velocity time graph for the complete motions of both stones A and B on the same set of axes, and then label our graphs stone A and stone B clearly. And you need to show 2 things on the graph: the time taken for stone A to reach its maximum height, and the velocity with which stone B is thrown downwards. Okay, so 3.1, let me just date our question paper, get some more space there. So this is question 3, November 2017, paper 1, right? Obviously it's grade 12. Okay, so the question there was calculate the time it takes for stone A to reach its maximum height. We're going to make use of the formula V, F is equal to VI plus A delta T. A or G doesn't really matter. Whenever something reaches maximum height, we do know that it doesn't carry on further. So the velocity will stop when it reaches its maximum height before coming down. So it reaches up, stops briefly in the air, and then starts coming down. So Vf is equal to 0. Okay, I'm choosing upwards as positive, so I'll have 12. My velocity will be positive. Okay, let me just put that there for everybody. Upwards is positive. 12 plus negative 9,8 delta t. This one will go all the way over to that side, make it at 9,8 delta t is equal to 12. And we'll divide both sides by 9,8. Therefore, leaving us with delta t, the time taken for stone A to reach maximum height, to equal 1,22 seconds. Okay, which I think was quite simple enough. 3.2. Let's just go have a look at 3.2's question. Okay. 3.2's question, was before we get there, at the same instant that stone A is projected upwards, stone B was thrown downwards, and we had unknown speed of v. Okay, when stone A reaches its maximum height, stone B is 3v. Calculate the speed v with which stone B is thrown downwards. Okay, I'm going to make use of exactly the same formula. Vf is equal to Vi plus, I'm going to use G instead of A now to show you that it doesn't really matter, delta T. Okay, now, boys and girls, ladies and gentlemen, okay, I'm going to change my direction now because I'm more concerned about B's direction, stone B. Okay, so I'm going to make downwards by positive value here, or my positive direction here, because I'm trying to calculate V, and V that is unknown is associated with stone B, and stone B is going downwards. Okay, so what's our time going to be in this equation? It's going to be equal here, because this is the time that stone A reached its maximum height, but this is also the time it took for the speed of V to get to 3v. So the final velocity should be 3v. Vi should just be v plus 9,8 times 1,22. Okay, so if I take v over 3v minus v, we know simple algebra is 2v is equal to 9,8 times 1.22, which gives us 11,956. It's not my final answer, so I'm not going to round off. Divide both sides by 2, and we get our answer to be to 2 decimal places. Therefore V is equal to 5,978, so 5,98 meters per second. Okay, and there is a range mark for this question saying that if you selected 6 meters per second, you would still get the answer correct. Okay, but I rounded off to 2 decimal places, so because I had 3 initially, so I rounded it off to 2, so that's 5,98 meters per second. If you said 6, still get the correct answer. Now we're heading off to 3.3. Now it says that at the instant stone A passes its initial position, on its way down, stone B hits the ground. 3.3, calculate the height h. Okay, so let's read it again. At the instant stone A passes its initial position, which is over here. So when it reaches its maximum height on the first journey, it starts to come back down. So when it passes its initial position, which is over here, this horizontal line here at the top, okay, stone B already hits the ground. So about after 1.2 seconds, which I would say is round about here, stone B is 3v. So you can calculate 3 times 5,98 to get what was its velocity around here. Okay, and then when after another certain amount of time, stone A then passes its initial position, but B has already hit the ground. So we need to calculate height h. Okay, so there we go, 3.3. Okay, so I think I'm going to choose, let me see, I think I am going to choose downwards as positive again. So I'm taking my downward direction as positive. So I'm going to use the equation delta y is equal to vi delta t plus half g delta t all squared. Okay, delta y is what I'm looking for. Right, initially v was 5,98 times, now watch this, 2,44 seconds. Okay, plus a half times 9,8 times 2,44 all squared. My question to the class is, why have I not written delta t as 1,22? Why have I used 2,44? Would anybody like to shed light on that? Anybody have a possible reason why? Anybody? Alright, so that was an excellent explanation there by one of the students, saying that of course it's double the time. Okay, intuitively we can see the time is double, but why is the time double? So just to take the student's answer and just maybe put it into better perspective or into a clearer light, is that, remember, the question said that once object A comes past its initial point from where it was thrown, stone B hits the ground. So if we look at stone A, just focus on stone A for a minute. Stone A goes up here. This is max height of stone A when it was thrown up. This time here is delta t is equal to 1,22 seconds. But now, of course, it's not exempted from falling prey to gravity. So what happens? Obviously, once it's there, it makes a turnaround point and starts to come back down, back to its A's initial point, which was over here. So what is delta t equal to here? The same time, 1,22 seconds. So this time for it to go up and the time for it to go down is obviously double. So the same amount of time it took to go up is the same amount of time it takes to come down. So 1,22 seconds times 2 gives me 2,44. Now notice that's just of stone A. So in this time when stone A was doing this, stone B, when stone A was going up, stone B landed about like here. Okay, this is stone B. And this part was about 1,22 seconds. And when stone A went past this little point here, stone B hit the ground over here. And that time too still adds up to the same amount of time, 2,44 seconds for stone B to hit the ground. That's why we've used 2,44, as it's the total time taken for stone B to do all those things while stone A was doing its own thing. Same time, because they were released the same time. While stone A was going up, stone B was dropped. Does that make sense to everybody? Makes sense to me. Okay? Although it does take a while to sometimes process if you're thinking two things at the same time. It's just vertical projectile motion, guys. It's just how it goes. But let's come back to the calculation quickly. So 5,98 times 2,44. Okay, we can just take that calculation and put it all straight in on the calculator because there's like nothing missing. No variable that's unknown there besides the one on the left. Plus 0,5. I'm going to use decimals all the way. Times 9,8 times 2,44 all squared. That gives us a long answer of 43,76384. So I'm going to round it to 3 decimal places. So 43,76, well, it's 84, so 8 rounds up to 3204. Okay, and now that I got that, I can actually further round up my answer to 2 decimal places. So therefore, delta y is equal to 43,76 meters. Okay, if we decided to round up from the 7 upwards and to round it up to a whole number of 44 meters, you still would have gotten the correct answer. Okay, as there's also a range that they would give you the right answer for, depending on numbers used. Okay, so the height, which is equal to h, okay, or delta y, so therefore h is equal to 43,76 meters. Beautiful. Okay, that was a beautiful question. And then, of course, the next question was draw the graph. Okay, draw the graph. And it all depends on which motion you are taking as positive. Okay, so I'm going to draw the graph for both. Okay, sketch the velocity time graph now for the complete motions of stones A and B, but on the same axis. Alright, or axes, and we need to label our graphs, which is B and which is A, and we need to show 2 things on the graph. 1, the time taken for stone A to reach its maximum height, which is 1,22 seconds. That needs to be present on the graph. And then, of course, the velocity with which stone B is thrown downwards. That needs to be present on the graph as well. Okay, so this is upwards as positive. Okay, so I've got my graph over here. I've got time, which is in seconds, and I've got velocity, so I have to write on the side in meters per second all squared. Okay, and so this is upwards as positive, so time it takes for stone A, so I'm going to start here. Cool, so that time is 1,22 seconds. Okay, and obviously now as we reach into the negative zone over here, we obviously know that this is where A decides that it's going to what's the word I'm looking for? This is obviously when A, this is A over here, so I'll label it like this. This is where stone A is now coming down. Alright, it's now coming down. Okay, I don't need to indicate the velocity here. So then over here, I indicate for stone B 5,98. Okay, so this is 1,22. So I've kind of drawn this graph slightly a bit too low, but it's fine. I'll just have to go over the GBB logo. It's all good. So now obviously the graph now is going to continue. I'm just going to extend this line through here. So now B, the initial one, okay, A goes all the way through because this is A takes this amount of time to now hit the ground because it's going up first, then down, and B just has a straight downward motion like this, and then we just indicate with a dotted line. Obviously your line will be a bit straighter, saying that B, which is about the same distance here to here, here to here, this would be 2,44. We don't need to indicate that one. Okay, we don't need to indicate that one. Okay, but basically saying that after 2,44 seconds, double this time that it reaches the ground. Okay, and that's for upwards as positive. Okay, for downwards as positive, the graph is going to look exactly the opposite. Okay, so A over here is just going to start from the bottom, and then B is going to continue going from the top. But I'll still draw it so you guys can get perspective. Okay, we push this all the way through to the top here. So, okay, so this is downwards as positive. Okay, let's see if I can just draw a little bit up here. So this is V in meters per second. This is delta T, which is in seconds. So what happens now, A starts at the bottom here. It keeps on going. Okay, label A. This is 1,22. So I'll put it at the bottom here. And then B starts here, which is at 5,98 meters per second. And B just continues to go upwards like that. Okay, and I'll just extend my little line up further here. Okay, there we go, let's get it there. And then you just drop a line nicely over there, showing that that's when it's hit the ground. Okay, you won't put in that time. Okay, so it's just the complete opposites, of course, and obviously your lines will be a bit more straighter than mine. Okay, but your graph is correctly labeled, 4 marks, and you've shown graph A and B, and you've shown what they have requested, the time for A to reach maximum height and initial velocity of B. And that's the end of that question. As you can see, it was quite a nice question for 14 marks, so about 14 minutes to complete the question. And with this question, we end off our lesson for today, grade 12s. Thank you so much for joining me. And we will see you next week. We will continue just maybe in increasing our knowledge in the fundamentals of VPM questions. And then we will move on to our next topic shortly.